In the engineering field, we deal with measurable quantities. Our measurement, however, must be communicated in a standard language that virtually all professionals can understand, irrespective of the country where the measurement is conducted. For our country, we're using International System of Units, or SI, adopted by the General Conference on Weight and Measures in 1960. In this system, there are 6 principal units from which the units of all other physical quantities can be derived. There are 6 SI units that are used in the engineering field. The quantity that is represented by the basic unit is length, mass, time, electric current, thermodynamic temperature, and luminous intensity. The basic unit that the SI units represent are meter, represented by the letter M, kilogram, represented by the letter kg, second, represented by the letter S, ampere, represented by the letter capital A, Kelvin, represented by the letter capital K, and candela, represented by the letter CD. One great advantage of the SI unit is that it uses prefixes based on the power of 10 to relate larger and smaller units to the basic unit. There are few SI prefixes that is used throughout the engineering field: exa, peta, tera, giga, mega, kilo, hectare, deca, deci, centi, milli, micro, nano, pico, femto, atto.
So, I want to continue about electric charge. What is charge? Charge is an electrical property of the atomic particles of which matter consists, measured in coulombs. So, each atom consists of electrons, protons, and neutrons. The nucleus is positively charged and has the proton and neutron. Electrons are negatively charged and it is in discrete shell. In neutral atom, the number of electrons is equal to the number of protons. One electron is equal to 1.602 times 10 power of negative 19 coulombs.
Now, we are going to talk about another important part in the circuit, voltage. It is named after an Italian physicist, Alessandro Volta. Voltage can be defined as the amount of potential energy between 2 points on a circuit. This is because in a branch of a circuit, one point will have more charge than the other one connected serially to it. The difference in charge between those 2 points is what we call voltage. The unit is volt and is represented in the equation as the letter capital V. To further understand the basic concept of the electrical circuit, the situation can be defined as a water in a pipe with a narrow diameter on the other half. From here, we can see that the water represents the current that is in a circuit. The force that is pushing the water represents voltage, and the narrow diameter part of the pipe is the resistance. While the current remains the same, if the narrow part of the pipe is to be reduced, a higher force is needed to push the water down the pipe. It can be said the same for the current in a circuit. More voltage will be needed if the resistance in a circuit is increased to prevent loss of current.
What does power mean? Well, power by definition is work over time. How much work you can perform per unit time? Now, it turns out that pushing charges through a circuit takes work. The more charges you push through a circuit, the more power it requires, or the faster you push charges through the circuit, the more power requires the battery or any sort of power source will provide that power, and the equation that we use to indicate how much power the battery produces is equal to the current that the battery pushes through the circuit times the voltage that the battery has.
Electrical energy in circuit. Electrical energy is the capacity to the work, and the unit of work or energy is the joule. Electrical energy is the product of power multiplied by the length of time it was consumed. So, if you know how much power in watt is being consumed and the time in second for which it is used, we can find the total energy used in watt second. In other words, energy is equal to the power times time, and power is equal to the voltage times current. Therefore, electrical power is related to energy, and the unit given for electrical energy is the watt second or joule. What is the electric circuit? Electric circuit is an interconnection of electrical element. Element is the component that used in electrical circuits. The basic electric circuit theory course is the most important course for an electrical engineering student. Electric circuit requires an interconnection of electrical devices. The components of the circuit is known as an element. They are simple circuit and a complicated circuit that they are used in numerous electrical systems to accomplish different tasks. Our objectives are to study of various uses and application of circuits. These concepts include charge, current, voltage, circuit element, power and energy.
In the circuit, we have circuit element. There are two types element in electrical circuit, which is passive element and active element. An active element is capable to generating energy, while a passive element is not. For active element, there are two kinds of source, which is independent source and dependent source. So this is independent source, while this is dependent source. The passive and active component. There are some examples of passive component, which is resistor, capacitor, and inductor, while the active components are transistor and integrated circuit.